All right, I'm going to go over the first problem here. It reads, for parts A through C, use the similar triangles below. Similar triangles just mean two triangles that are scaled copies. It's just different language, but it's the same thing that we've been talking about. So this first problem is going to be a review of what we have done with scaled figures. What is the scale factor from the smaller triangle to the larger triangle? So what we want to do here is pay particular attention to the language. So I'm going from smaller to larger. So this is really where you want to be in the habit of drawing in that arrow. So in the problem, I drew the arrow from one to the other in the manner that they're asking me. I'm going to draw my matching arrow in the picture. So smaller to larger, because I have the knowledge that whenever I go to find my scale factor, if I draw the arrow in, I know I take the end of my arrow divided by the beginning of my arrow. So if I need to find that scale factor from the smaller shape to the larger shape, I'm going to take corresponding sides in my larger shape divided by corresponding sides in my smaller shape. Okay, so the end of my arrow divided by the start of my arrow. So if I want to pick out a pair of corresponding sides, I'm going to highlight them through. 8 corresponds to 10. 12 corresponds to 15, and 16 corresponds to 20. So if I already know from the problem that they are similar triangles, it means they're scaled figures. It means that I can just take one pair of these corresponding sides, it doesn't matter which one I use, and I'm going to divide them out. So again, I want to make sure I'm following my arrow and taking the end of my arrow divided by the start of my arrow. So if I go ahead and do that, I'm going to pick my blue lines, and I'm going to do 20 divided by 16. So you can divide that through in your calculator. If you want to practice with your fractions, we want to reduce this. So what can I divide 20 and 16 by? I recognize that both of these can be divided by 4. If I do that, I'm going to get 5 over 4. So my scale factor is 5/4. If I wanted to go ahead and make that into an improper fraction, I would have 4 goes into 5 once with 1 left over. So I have 1 and 1/4. Or if I want to go ahead and make that into a decimal, 5 divided by 4, I get 1.25. So my scale factor from the smaller to the larger is, I'm going to use my improper fraction of 5 over 4 or 1.25, okay? And I'm using this version of 5/4 to point something out when we get down here. That's going to review something we talked about earlier on in this unit. Moving on to the next question, it says, what is the scale factor from the larger triangle to the smaller triangle? So I'm going to draw that arrow in again. So from larger to smaller. So now I'm going the other direction. I'm going from my bigger triangle to my smaller triangle. So if I go ahead and pick a different pair of corresponding sides, I'm going to make sure I'm following that same rule where I'm taking the end of my arrow divided by the start of my arrow. This time I'm going to go ahead and pick my yellow sides. It doesn't matter which ones I pick. I'm going to just go ahead and do that. So I have 8 divided by 10. And then I'm going to go ahead and reduce that fraction again. 8 and 10 can both be divided by 2. If I divide both of these by 2, I get 4/5. Okay. Notice here what happens. We talked about this a little bit in lesson 5 whenever you watch that Edpuzzle video. My scale factor from small to large was 5 over 4. My scale factor from large to small was 4 over 5. Notice how those fractions are opposites. If you're doing a problem like this or looking at figures, if you need to figure out scale factors from one to the other and then back again, they're always opposites. If my scale factor was 2/3, then the opposite one would be 3 over 2. You can always just flip it. Okay, so my scale factor from large to small is 4 over 5. And then if I went ahead and made that into a decimal, we would get 0.8. Okay, so the scale factor from large to small is 4/5 or 0.8. And notice that that falls right in line whenever we were talking about the size of the scale factor. So from the smaller shape, it's getting bigger. So my scale factor is bigger than 1. But then from my larger shape, if it's getting smaller, that scale factor is less than 1. Okay.